Okay guys, I had a request for the second part of number 14. It says a famous leaning tower was originally 186.5 feet high. At a distance 120 feet from the base of the tower, the angle of elevation to the top of the tower is found to be 65 degrees. Find angle RPQ indicated in the figure. Also find the perpendicular distance from R to PQ. So what I did is I drew the triangle down here. You'll notice my triangle is more slanted, but I just wanted to do that so you could see the height. So I just labeled my angles P, Q, and R. They're asking us to find RPQ, so I'm just calling it P. I use my law of sines to find R first. So I have this distance is 120, this is 186.5. So I use the sine of 65 over 186.5 equals the sine of R over 120. When I found my R, I found it to be 35.7 degrees. But that's not the angle they want. They want P. So I did P plus Q plus R equals 180. And I found that P equals 79.3 degrees. Now I go to right triangle trig, go back to right triangle trig to figure out what the height is. So see, I drew it here. What I did is I just used a normal sine of P equals opposite over hypotenuse. So my sine of P, I kept it to more decimals whenever I did it in my calculator. So sine of 79.3, I think it was 2.3 or something at that point before I rounded here. So I did the sine of P equals H over 186.5. I plugged it in my calculator, multiplied by the 186.5, and I got that the height was 183.27. It's one of those problems that you go back just to normal right triangle trig to find the height. And I tried to make it a little more exaggerated up here. Okay, let me know if that helps. If it doesn't make sense, email me questions. Okay, bye.